right, now Dr. V is joining us again for the awesome time with Weird Science. Now, it's sunrise. We always like breakfast and eggs, but Dr. V, what kind of experiment do we have going on with eggs today?
This was real fun experiment.
Okay, cool.
And we did put something on the top of the table.
Oh, some napkins because it's going to get a little bit messy? That's
No,
what
let's just do it straight
All right,
forward.
no, okay, wait. Before we do that, I got to ask, how did you get the eggs in these bottles here? That's before.
You see the eggs in there? That was a tough one.
Yeah, that was a tough one. Did you have to get the chicken to help her?
No,
oh, you
we
cut off the
actually
top?
cut the top
Okay,
and
so you
then
cut
put
off
it
the top, taped it back on, get the eggs in there. But
Right.
before we get to that, what are we doing here?
So go ahead and drop this egg.
Really?
Yeah.
Just drop
Hold
it right here?
Hold it straight up
Okay,
and
so
then
I'm
drop it.
and on the table?
Yeah.
Okay.
Go ahead.
I noticed you stepped back here. Okay, here we go.
Okay.
There we go. The egg cracked, it broke, the yolk and
Interesting, we
everything's
didn't mess up.
out. Yeah, not too bad, but we definitely hit it hard there. So.
Okay. So we actually cracked the egg.
Yes.
Mainly because when the egg comes on here, it comes at a velocity, right?
Yes.
All of a sudden you're just stopping it. That means you're applying a lot of force, but it's acting at one point.
So the shell cracks.
It just cracks.
Gotcha.
But the next step is we are going to try to distribute this load and then see if we can do it.
So to protect the shell,
Protect the shell.
Okay.
So go ahead and, in this case, this bottle has water, regular water.
Regular water.
And this also has regular water.
But I noticed there's a difference here. This egg is kind of sitting on the ground and this is kind of, well, floating actually.
Well, the big difference is that this is salty water. And so there's a big difference in the density.
Okay.
So the density gives you the buoyancy.
So this is like the ocean right here?
Yeah, this is like the ocean.
And this is like regular water. Okay, so what do I do next?
Go ahead and drop the regular water.
Okay, so it's the same height as here.
And drop it.
And I'm going to go ahead and drop this. Okay, here we go. One, two, three.
Okay.
What happened? What happened?
It cracked, I think.
Did it crack?
Almost.
Did it crack?
Try one more.
Okay, try
to
it
make
one
sure.
more time. Here we go. Again, I don't want to hurt our cameraman. Craig is being very, very, very brave.
All right, it almost survived.
Okay, I see a little bit of a cracking on there on the bottom and stuff like that. Here, I'll drop it one more time just to be safe here. One, two, three. All right.
Okay.
So what's happening with this one and what's going to be the difference here?
Let's try this one then.
Okay,
Last one.
go ahead.
This is actually salty water.
No, I'm going to take a step back and you do it. That's a saltwater one. Oh. I don't even think the egg bounced to the bottom of the...
Right, there's no crack and it's pretty safe, right? And then the main reason is that this is giving the cushion, the buoyancy, and it, even though it's actually stopped all of a sudden the similar way as this one is stopped, but the force is applied uniformly around.
Wow.
So you have a padding, and it gives you the cushion, and it gives you the force distribution around the shell.
I mean, it's really amazing. It's almost like a baby in a mother, right?
Surrounded by the amniotic fluid.
Wow,
Yes.
that's very, very cool. Well, again, this is a great experiment while it's being
Yeah, one
very
more
little
egg you
messy.
can
We
drop.
got one more egg to go. Okay, remember, this is what happens when you don't have the cushioning of water around it. Again, we'll have all the information on the web. Thanks again, Dr. V, and thanks for watching us here on Hawaii News Now. Very cool. That's amazing.